Hi everyone. First of all, thanks for the ClickHouse team for having me. A little about myself. My name is Utkarsh. I'm currently working with Physics Wallah. You must have heard of Physics Wallah. It's one of the biggest edtech platform. It's a multinational edtech platform right now. And back when I joined in 2023, we had some problems around data, and that's where I came in to solve those problems, and one of the obvious solutions was ClickHouse. So let's explore how we got around using ClickHouse, why ClickHouse, and let's see the agenda. So as you can see, the agenda is clear here. We will first dive into what was the problem statement when I joined Physics Wallah, few solutions around it, the implementation, challenges that we faced, and the impact of the solution that we provided, areas for improvement, and then followed by a Q&A session. Okay, so the problems that we face, so about Physics Wallah, it started out as a very small company which grew into a very large company in a very short amount of time. So the problems were obvious that there were a lot of tech debts that we were having. One of the tech debts that we were having was that we did not have a time series database. The way we were storing all the data for our user-facing analytics was using MongoDB aggregates, which all of us know that there is a limitation to it, and we cannot use that for comparison if you want to do comparisons like year-on-year comparisons. And the cost. So Physics Wallah is a very economical product when it comes to its competitors. Like all the competitors that you might know, it's very economical in terms of the charges that we are charging the customer. So we needed a solution that is of low cost, stays aligned with our cost-sensitive business, and also able to serve few hundred TBs of data. The time. So I joined Physics Wallah at a very crucial stage where we were already missing the timelines, the projects were delayed because, and the most important part, we could not roll out few innovative products because we did not have a time series database. So I'll talk about more in the coming slides. The solutions. So if we were to explore solutions to the problems I previously discussed, there are a lot of options, right? You can see we have, if you want a time series database, you can use Pinot, you can use Apache Druid. If you want to save cost, you can use Postgre with extension. And if you want to save some time, you can quickly build a streaming processing stack using Flink. But what is the common denominator here? The common denominator of all these problems was ClickHouse, solutions, was ClickHouse, that I figured. I also had a history of working and using ClickHouse back from 2020, where I was working in a two-person startup, and I had the opportunity to build the infra, the backend, data, security all by myself, and thus I shifted towards using ClickHouse. So the implementation, when I talk about, is compared to back in 2020, ClickHouse has evolved a lot when you talk about the implementation side of things, especially if you want to deploy your solution in a cloud-based environment. So we are using AWS Cloud, and we are using EKS for our pods, and EBS volumes for the storage. We are heavily using the Alternity ClickHouse operator in EKS, and the CRDs provided by the Alternity as well. All of these are open source, except of course the cloud, the infra. So the typical flow of data in ClickHouse in Physics Wallah is something like this. We have completely phased out writing applications which writes data into ClickHouse, because ClickHouse does that very well for you. You don't need that actually. What we have done instead is put all our data into a Kafka topic, create a Kafka table, or they call it as a queue, use a materialized view, put the data whatever way you want into your tables, and then you can have, of course, you have the keeper, you have the EBS volumes to back your data. It's as simple as that. Now that I think back, this was done in around 3 to 4 months of time, all of this. But now when I think back, these are the challenges that I face. Now these things are very easy. I can solve it right now. But at that time of implementing ClickHouse in our EKS, these are the challenges that we faced. Let's talk about it. Choosing appropriate infra. So we had to be very cost sensitive, deciding where we want to put our money, okay, and how we want to put our money. So we could not just, there is a saying that you can throw money at every problem and it gets solved. But that was not an option for us. So we had to very sensitive towards choosing the appropriate infra. The ClickHouse cluster configuration. We are not running a vanilla ClickHouse. We are using alternate operator. And the thing with that is you need to understand how they have changed the way you configure your ClickHouse cluster. So this was one of the major challenge, understanding how to run the ClickHouse cluster inside EKS using alternate. Data ingestion, like I said, earlier back in 2020 when I was using ClickHouse, I was putting data into ClickHouse with some applications, and I faced a lot of problems because ingesting data into ClickHouse with your own writer is very complicated because you tend to end up writing in multiple rows, or you tend to write data which is not well formed to be written into ClickHouse. Data manipulation. So if we talk about Physics Wallah, there is a lot of clickstream data that we are receiving from the students. They are watching the videos, they are interacting with the teachers, they are interacting with their peers. So all of this is happening through the platform. Now what happens is you get a very complex or a nested JSON as a data input from the front end or from your applications. Manipulating that data on the fly was not an option if we talk about using Pinot, for example. But ClickHouse using MatViews was one of the reasons that we were able to manipulate data. More on that. Cluster performance and visualization. So as an open source tool, we did not have much information how to get probes into our cluster. We were clueless how to monitor these things, the cluster performance. So let's say choosing the right infra becomes a part of cluster performance, because if you don't know what your cluster is using, whether it is using it properly or not completely, you need to have the right visualization tools. And then backup and DR, most importantly. So the organization Physics Wallah is famous nowadays, and it gets attacked by a lot of hackers these days. So we need to have a very strong backup and disaster recovery mechanism as well. And the solutions. So for infra, we decided to go to use on-demand instances with node tainting and Graviton nodes. So Graviton nodes got released really early this year, or probably last year. This change helped us a lot in increasing the performance of the cluster, especially on the node level. Cluster configuration. So like I said, adapting to alternatives way of supplying ClickHouse configurations in the CRDs. I can dive more into that later on. Data ingestion. So like I showed you in that diagram, that we cut out all the applications or the development effort by just using Kafka tables. So we just put our data in Kafka and get the data ingested into ClickHouse. Data manipulation. Using MatViews, like I said, the complex JSON that we were getting are now being solved by using MatViews and running aggregates as well. So one of the products that we are having at Physics Wallah is a gamification app called as Learn to Earn, where students come and they see the videos, they see the lectures, they perform tests, and for those they get points, they get coins, and they get promoted, they get demoted. So this product is only possible because we are having something like running aggregates in ClickHouse. And we were not having this product before because we could not even imagine how to deal with this kind of data. And when I'm talking about this kind of data, I'll talk more about what is the load that we are getting on ClickHouse. cluster performance visualization was achieved by using Altinity's Grafana dashboard. That is a very helpful tool. And we have also built few dashboards on ourselves. I'll show you that. Backup and DR. So this is still a little bit of a problem that we are facing. And the problem here is the full backup that we take on ClickHouse. So our tables are huge. And when we do a full backup, we need to blend it with a set of incremental backups. You cannot do full backup every day in ClickHouse. It will literally bring down your cluster. So we need to blend it with incremental backups. And the way we did it is on every 1st and 15th of every month, we do a full backup followed by all the days we are having incremental backups. Now let's talk about the impact that ClickHouse has made to Physics Wallah. So let's talk about the innovation part first. Before 2023, we did not have products like Learn to Earn, Doubts and Comments, Student Parent Dashboard. Even if they were existing, they were not functional to industry standard where we can say that, hey, look at this dashboard, you can do analysis and comparison, because we were storing data in Mongo aggregates. It did not give us that leverage. So currently, more than 5 critical customer-facing products are now powered by ClickHouse. Next comes the speed. Now, speed is important for us because we are using ClickHouse as a user-facing product, okay? We are not using it for internal applications. We have made it very sure from the start that we only want to use it for user-facing. And we have the trust for it. That's why we are using user-facing. And we are able to serve around 3K QPS with a P99 of 190 ms without any caching layer in the between. And on a table which has more than 5 billion rows. Now comes the performance part. We are able to, as of now, we are able to currently ingest 50 million records per day in ClickHouse just by the process that I showed you, just using Kafka tables, with a speed of 20K records per second. And according to me, it's a really good performance metric if you want to compare, if you want to adapt to ClickHouse. And it really changes the game for you when it comes to serving users in real time. The scale. So currently, Physics Wallah is having around 10 million, more than 10 million users with a daily active user base of 1.5 million. So when our classes are happening from 4 to 7 p.m. in the evening, we are getting huge load of traffic. And we were able to achieve or serve that traffic using ClickHouse and also provide horizontal scaling. So you would ask, okay, how is it possible that you are going with horizontal scaling using using EKS with a stateful set? Well, the answer is simple. We, as Physics Wallah, only need to keep data for 2 years for a student, let's say, because he or she, if she joins in class 10th or 11th or 12th, the data is only there for 2 years for a user. And we don't really need sharding in that way. So when you don't really need sharding, you only need replication, you only need high available database, you can easily do horizontal scaling as well. You can increase or decrease number of replicas that is running in your cluster. And the cost part. So when we were storing data in MongoDB, we realized one thing as well, that there is a lot of duplication that is happening. Same data is getting stored in one table, another view of that data is getting stored in another table, and a lot of duplication was happening. And because of that, we were paying a lot to MongoDB. So when I introduced ClickHouse to Physics Wallah, we decided we wanted to have a raw layer of data where we can transform data as per our choice whenever we want, because we have the raw layer of data. So these are the impacts that ClickHouse has made, few impacts, I'd say. Moving on to the next slide. There are some areas of improvement that I am currently working on. That is the cost. First of all, the cost. Right now, combined cost of the staging, development, production clusters of ClickHouse is around $302,050. for us. Now, when I started out in Physics Wallah with ClickHouse, we only launched one product called as the Academy. But as we saw that it was able to handle the load and people were getting, having the confidence, now every product wants to move to ClickHouse in Physics Wallah. And the problem that we are facing is we have only one cluster. We don't have multiple clusters that we can afford or maintain as a part of the DevOps team. And if one user is performing bad queries or isolation of users need to be done in a very critical way so that multi-tenancy can be achieved and without any issues. So this is one issue that I'm still working on. Schema evolution is one of the parts that happens because the front end in the companies keep sending different schemas every day, and some new fields get added, their types get changed. So this is one of the issues that I'm facing, how to solve this. And backup and DR, I think I already discussed that full backup table, backing up a full table is very costly in ClickHouse. So I'm still trying to figure out what can be done here. That's all from my side. Special thanks from my side to the ClickHouse Cloud and open source community and the Alternity team and my folks at Physics Wallah for showing the confidence in me to work and produce a database, set up a database basically to be leveraged and used. And that's all from my side, guys.